Hey there, Susan. I'm so sorry. I just saw this email just now in my bunch of emails, and I know you sent this on Monday, but I just wanted to quickly go through question 4 and question 5 to explain that. And in terms of the online platform, I know the revision sheets on Friday and Monday, because I had course counseling all day. I wasn't in class, so that was only digital. But the one that you're asking now, that should be hard copy. So that might have been the only one that he has that is hard copy. And I'm assuming that's the one he's doing right now. And solutions for the practice multiple choice questions that you're asking is on the OneNote. So on the OneNote with all the other exercises, each one having a video example and working solutions for them. For the Chapter 13 revision worksheet, the one that you're looking at, students have the hard copy, and then digitally I've put up the solutions here for them to review. So let's have a look at question 4 and question 5 very quickly here. Question 4 talks about this statement here. Now the solutions are over here, but this is assuming that students understand the logarithmic rules. There's about 5 of them. So here we've got log base 6 of 6 to the power of x plus 2 is equal to 3 times the log base 3 of 6. How they got their first line, so notice x is removed, is simply using rule number 3. They're saying rule number 3, you can bring the power down, so it becomes x log base 6 of 6. But we know that log base 6 of 6 is equivalent to 1. So hence x multiplied to 1 gives you x. And that's where they got x plus 2 on the left-hand side from. Okay? And then the next part is they broke up the 6 into 3 times 2 because you can then use rule number 1. So here what this means is 3 times log base 3 of 3 times 2. Using rule number 1, we know we can split this log into log base 3 of 3 plus log base 3 of 2. And here we got, don't forget the 3, it's being multiplied to the entire term, so make sure to put the brackets around them. And here we can see that log 3 of 3 is 1, and then you've got brackets 1 plus log 3 of 2. So when you expand the brackets, make sure to multiply 3 to both terms. So that gives you 3 plus 3 log 3 of 2. And over here on the left-hand side was still x plus 2. So that's how they would have said, all right, to find x, I'm going to subtract 2 because that's a plus 2. Opposite of plus 2 is minus 2. Minus 2 on both sides to keep the equation balanced. And that's where 3 minus 2 is 1. And that's how they got their final answer is x is equal to 1 plus 3 log base 3 of 2. So that's where that comes from. Okay? And then question 5, because this is asking for which equation is false, it looks like there are 2 methods here. You can either try to solve for A or you try to solve for D. So in both cases here, you got a to the power of d is equal to 7. If you were to solve for d, it means that you need to remove the base a. And to do that, we do the inverse of exponential, which is logarithmic, and that will be log base a on the left. And then whatever you do to the left, you do to the right. So log base a of the right-hand side. That now gives us log base a of a to the power of d is equal to log base a of 7, because I'm doing log base a of both sides, right? And then using rule number 3, we know that we can bring the d down again, just like before. So it's d times log base a of a, which we know cancels out to be 1. That's how you get d is equal to log base a of 7, which, if we look at the solutions, that is true. So that means that a is okay. And then the other one to compare with is if I've got a to the power of d is equal to 7, well, what if I want to solve for a? It means I need to remove the power of d. And we know through index laws, a to the power of d, you can do the power of the left-hand side, you can do all to the power of 1 over d. Which means now you're going to do the same for the right-hand side, so it's 7 to the power of 1 on d. Why? Because we know in our index laws, d times 1 on d, so this is using index laws, you can multiply the powers together, so it becomes d times 1 on d, which we know is d divided by d cancels that to be 1, and that's why it ends up being a to the power of 1, which is a, and then this is 7 on 1 on d. Okay, so that's one way to do it. Alternatively, you can use your one of your index laws, where you've got a to the power of m n is equal to a to the power of m over n, right? So in that case here, you can transfer that into as the a to the power of d in terms of the root, and so it's root d, if you want to think of it that way. And so you can say, how do I explain this? You can change it. You can think of it as, if I change the 7 as 1 on 7, okay, so if I did the reciprocal on the right, then I'll do the reciprocal on the left, and you can see here that the reciprocal, if we rewrite that, that's the same thing as a to the power of negative d is the same thing as 7 negative 1. Another way of playing around with it, you could also try, if I wanted to get rid of the d, we can do the dth root, if that makes sense. So for example, if you had a to the power of 3, you can do third root, and that cancels out, right? If you had a squared, then square root cancels. If you had a to the power of 4, then fourth root. So then what if you had a to the power of d? You can do the dth root, if that makes sense. So that's another way to also approach it as well. You could have done the dth root on both sides, so dth root on the left, and then on this side here, dth root of 7, and dth root is the same thing as 7 to the power of 1 on d. Okay, and that's based on this rule here. Okay, that's the idea. If that's based on the idea of 7 to the power of 1, and d is the denominator, and so that's how you can do a comparison, and you can say, well, actually, all of them are the correct one except for a is equal to 7 to the power of negative d, because we already figured out before a is equal to this 7 to the power of 1 on d, and 1 on d is the same thing as saying 7 to the power of d to the power of negative 1, okay, which is